Mr. Sandeep Vasant. He is Head of Sales and Business Development, India Hyperscale Datacentre at Fläkt Group India. He has more than 14 years of experience in the field of HVAC solutions, including chillers, air handling units, precision AC, free cooling units, etc. He is mechanical engineer from MS Ramaiah Institute of Technology, Bangalore. He is a certified data center professional, Indian Green Building Council, Accredited professional, and Green Eco-Friendly Movement certified professional. He is also an active member of ISHRAE and Rotary International, Bangalore. Today, Mr. Sandeep will give us a review on free cooling in data centers. So delegates, let's welcome Mr. Sandeep.
Our vision, we aim to be the leading strategic partner for smart energy, efficient indoor air and critical air solution, and be recognized by our customers as the technology leader, providing highest quality standards for improved air comfort, safety and well-being. We want to be the place where people are proud to work. I think the vision is in line with the topic what we are discussing of efficiency in a data center. Key facts, the global number, we are present all over the place. Globally, we are present. Global numbers of Fläkt Group, 630 euro million, 3,600 talented employees, 170 dedicated R&D experts, 65 countries served worldwide, 30 manufacturing sites, 8 center of excellence. That's the number. These are the pictures of the global presence. Our factories are all over the country, all over global, in Sweden, in UK, in USA, in Czech Republic, and here goes our factory in India. We have our factory at Greater Noida in Delhi, and our sales offices are all over the place. And this factory caters to the entire Asia and South Asia market. The factory what we have at our Greater Noida is a state-of-the-art modern factory. We believe in Make in India, and we have been making in India over a decade. The factory is present close to from 1961. As I said, we have sales and services offices all over the place, be Delhi, Kolkata, Mumbai, Hyderabad, Bangalore, and Pune. I'm based out of Bangalore. As I talk, you can see the video here playing. The people are busy working as I talk here, men at work. This is the peak of the factory. Just a quick small minute video of what the factory setup looks like. And as I said, we are Fläkt Group. From there on to kind of deep dive into the Fläkt Group India numbers, total India turnover, year goes, and the manufacturing setup area, 10,000 square meters, 300 plus talented employee, including myself in that number, and the numbers are going to increase as we recruit more number of people. What makes Fläkt Group special is we are a complete HVAC company. When I say HVAC company, we have air handling unit, the fans, and the precision air conditioning units which goes into the data center. These are the number, the annual capacity, single shift, which the units which goes out of our factory. So we believe in making energy efficient, best in class energy efficient solution. Entire overview of the HVAC equipment what we manufacture. As I said, the air handling unit. I'm sure all of you would have heard of our brand and would have directly or indirectly used our solution. Air handling units are there, air handling units with the controller. We have an in-house heat exchanger coil manufacturing, fans, and the close control units, which are the PAC units which we manufacture. And the speciality of all these products from Fläkt Group is each and every product is certified. Be it the PAC, this as a CE certification and the SASO, AMTA certifications on the fans, Euro 1 certifications on the AHU, and then we have an HRA certified coil. To kind of niche down on the solution, what goes into the data center, since we are talking about cooling efficiency, we have a wide range of precision air conditioning units solution from Fläkt Group, specifically for the data center, be it a small data center server room, 0.5 kilowatt to 14 kilowatt, a simple wall mounted precision air conditioning unit, both direct expansion and the chilled water on the wall. And then we go into a floor mounted up to 103 kilowatt. And then we have the multi-den. I'll be talking more on this solution and the free cooling. And this model has been proved better in terms of the efficiency, be it by a third-party lab or at our customers' place at any of the data center. We have seen that the power consumption of this unit is close to 20 to 30% vis-a-vis any of the PAC manufacturers globally and in India as well. The solution not only stops there. If you look at the hyperscale data center, which we see a lot of these projects happening in India. We have a power unit, a chilled water large PAC unit up to 500 kilowatt. And then we go into a fan wall unit. This is something emerging technology. I will talk on more on that on the coming up slide. And then the indirect evaporative adiabatic based cooling as well. So a complete range, a huge range, and the discussion not only stops here. All these units can be customized to meet our customer requirement and working towards a COP. So to kind of talk on the cooling efficiency for the data center, I have a slide here. So basically we saw on the solutions what goes from Fläkt Group. As per ISHRAE document specifically for data center, the HVAC cooling takes away 30 plus 8, 38%. That's a huge number. That is why we are discussing today what are the ways to improve the efficiencies. 38% is a huge number of the consumption of power in the data center from the HVAC. And another report also says that a downtime in a data center is also because of a human error. Wrong design, wrong solution, thereby your data loss and the data center is down. So this is an astonishing report which is given to us, and then we need to kind of work on the right solution. So to kind of talk on the data center efficiency, when you look at a complete data center, the math or the language is the PUE, power usage effectiveness, which is the math of facility, the power consumed by the facility, you have the HVAC as well, divided by the IT equipment. As I said in the previous slide, 30 plus 8, 38% is the power consumption. We would be focusing more on the HVAC today. On the PUE, just for the benefit of doubt for everyone, the PUE numbers are from 3 as down as 1.2. 3 means very inefficient, 1.2 means very efficient. The global average, as per Uptime Institute says, the global average is around 1.55. Again, depends upon the type of data center, server, location, heat load, and various other parameters. To go to the next slide, as I said, the PUE, lesser the efficient. Basically, if you see a PUE of 3 vis-a-vis a PUE of 1, if you do a simple math, close to 40 to 50% is the saving. So we need to focus on the PUE and on the HVAC of 30 plus 8, 38%. So we saw the precision air conditioning unit which sits in the data center. Number one is we need to select the best, most efficient component. As I talk, you can see the inverter compressor. Earlier we used to use fixed, but it's a request that everyone looks at an inverter compressor. What does an inverter compressor does? Lower power consumption at part load. A fan from an AC fan, today we are talking about EC fan, energy efficient, electronically computed fan, both in the indoor and in the outdoor, and choosing the bottom throw in a data center would be better because the cold air is heavy intensity and the hot air being low intensity would naturally go back on top of the unit. Choosing a valve from a thermostatic or electronic expansion valve, and then we are also worried on the GWP and the ODP, selecting of the green gas as well. As per the EC/BC norms, specifically on the PAC units which sits in the data center, the COP should be 2.5 to a max of 3 or above. Higher the better. What is COP? 3.516 divided by IKW per ton. IKW is the kW power consumption of the compressor, what we saw here. So higher the COP, basically better, thereby the PUE would also reduce. Also, India took a pledge at the COP26 that we go net zero carbon emitter. So I'm sure all of us should drive towards this and take the pledge towards a net zero carbon emission. From there, not only that, once we select the best efficient components, let us say we have a requirement of 10 TR into 5 and the 5th unit is a standby. So thanks to the inverter compressor, the EC fan, it's better that you run at the part load. Rather than keeping the 5th unit as a standby, it's better that you run all the 5 units at partial load to meet your requirement of 10 TR. What happens in that scenario? If you see, as per the cube root formula, at 100% if you run, the power consumption would be 100%. As you drop, thanks to the variable compressor, inverter compressor, EC fan, the power consumption at part load would be less. Thereby, if you see here, Operating the units at a 60%, power consumption would be 20, not 59, and thereby you get the benefit of saving close to 38%, not only in the PAC, also the chillers which goes into the data center. So this is one modification or suggestion what you can do. Next very important thing is the ASHRAE 2011-15 and the TC 9.8 document, which says to operate the cooling units in the data center between the gradient of 18 to 27. Here is the PAC, here is the rack. The supply air temperature is what I am talking here, between 18 to 27, and the hot air goes back to the unit. So there is a clear defined ASHRAE documents which is saying recommended A1, A2 and A3, A4 depending upon the type of server. I'm happy to see most of the data center end users, IT customers are sharing us the A1, A2, A3 and A4 gradient, thereby helping us to design the right PAC unit. Now, apart from the HVAC document, there is also a ISHRAE guideline which talk about to impede the COVID virus, and the temperature gradients are very much in line with the HVAC, that is between 24 to 30 and 40 to 70% RH. So thereby it is in line with the ISHRAE guidelines for the COVID. So this is to give you a history of the HVAC document. So what is the impact happens on the cooling unit if we use the HVAC 18 to 27 supply air temperature? I have taken a case study of a 30 TR. Normally, most of the time we find in a small server room, they say that let's operate at a low temperature. I should feel cold, thereby I assume that the rack also would feel cold. But there is a clear defined ASHRAE document which says 18 to 25 is the supply air temperature. So here is an example of a 30 TR with a supply of 10. I have taken it at a very low number. And here if you see the ASHRAE document says 18 to 24, you can still go up to 27. So if you see, by using the supply air temperature at 10 and the return air, most of the PAC units runs at the return air logic with a delta T of 10 gives a supply air temperature. So what happens is the behavior pattern of the PAC is the cooling capacity increases, the power consumption decreases. Thereby, a simple math, if you see running the unit at a return air of 20, or if you see the supply air from a 10 to 19, you get a power consumption saving of 50%. And the discussion not only stops here, ASHRAE says you can still go as high as 27, thereby you get a good saving. So to kind of niche down on the free cooling in a data center. So what is free cooling? I'm sure you would have heard of it. Cooling the data center space with the free ambient air, keeping in view of energy sustainability, and also important the ASHRAE 2011-15. Direct free cooling or indirect. What is direct free cooling? Simple, get the cold air inside, but obviously the outside air would have dust particle and all that. I live in a city in Bangalore. For the last 3 weeks, if you see, it's been raining and the temperature is close to Shimla, it is close to 23 degrees. We can practically get the air inside. Obviously, we need to filter it, but there are chances that we could get the direct free cooling done. If not, if the ambience are very harsh, most of the cities like Delhi, I keep seeing articles that there is a heat wave which is going on. So nevertheless, we can use the indirect free cooling equipment. So the same PAC, what we saw, would have another one circuit. So here goes a short video of how the working principle. The same cooling unit would have another circuit. One circuit would be a direct expansion, chilled water or dual. There would be another circuit of a free cooling circuit. When I say free cooling circuit, circulation of water to a heat exchanger, closed loop circuit. Along with that, you will have a direct expansion / chilled water / dual coil pipe as well. So let us say if the ambience are very low, like a Bangalore or wherever extreme weather conditions like a November, December, very low, obviously the free cooling circuit would operate. In this technology, we would restrict the movement of bad air into the data center. As the ambient increases, it goes into the mixed mode. What is mixed mode? Partial of this circuit and partial of the DX and the chilled water. Temperature very harsh, very high. obviously it goes into the DX mode. So this is an indirect free cooling technology which can also be implemented. As I said, there is a PAC unit, rack, a condenser, and there is a water circuit, and then there is a copper pipe which circulates the gas, or it can be chilled water. The outside air is not taken inside the data center. So to pull back that ISHRAE document 18 to 27, the principle of working of indirect free cooling unit is simple. I've taken a case study here of the supply air temperature, return air temperature of 30, return air temperature of 30, and RH external ESP. This is just for our discussion purpose. Ambient is low, I've taken at 20 just for our discussion purpose. So if you see the supply air temperature at 20, return air delta T of 10, minusing 5 offset temperature gets you 25. So let's say if we operate at this gradient, we can go up to this gradient, as I said, just for our understanding of this indirect free cooling. Anything above this set point would go into the direct expansion. Anything below would be the mixed mode. Anything very low where the unit can cater to the cooling would go into the free cooling circuit. So this is a circuit diagram. You can see there is a heat exchanger, compressor, one circuit. Second circuit would have a EC water pump, circulation of the water, and this is a condenser or a water cooled condenser can be connected. So to kind of pull back, thanks to a ISHRAE 8760Rs which I got it, basically I have plotted the graph of the different ambients in Bangalore vis-a-vis the operating temperature in the same indirect free cooling unit. If you see at a certain ambient, free cooling can be used so much of time, and then it goes into the mixed mode, and then we are restricting the usage of the direct expansion. So you get a saving here because your direct expansion comes into picture at a very limited time. So that's on the indirect free cooling. Again, a case study of 3070R airflow and the external static pressure of 50, supply air temperature 27, delta T of 10 with a 37 written ambient. With this case study, most of the time we operate with all the fans, with all the compressor, and if you look at the indirect free cooling, as I said, three methodology: only free cooling, only the fans, EC water pump, and fans comes into picture, thereby giving you a saving of close to 80% over the direct expansion. Even in the mixed cooling method, you get a saving of 30% over the direct expansion mode. So this is to kind of give you a flavor of the savings. This is just a case study saving what I have taken. We spoke on the POV as we started the discussion. What happens with the free cooling? Obviously the COP would increase, thereby the 30 plus 8, 38% would come down, thereby POV would also come down. Again, depending upon the site, application, the unit can be selected, and we could arrive at the exact COP and the POV numbers. Now, as we spoke on the ISHRAE 2011 and 15 document, which says clearly 27 is the supplier, thereby written with 10 or 12. With this methodology, the chilled water temperature from the chiller can also go high. So here is the typical methodology. So not only you get a saving on the PAC, also on the chiller. Case study of a chiller, let us say driving the chiller at 7-degree outlet, vis-a-vis 21, you get a saving of 50% saving. So this is something which we can also implement in the chiller. As I talk, you can see the PAC and the server rack supply and return, which I explained in the earlier slide. So a combination of both air side economizer and water side economizer, basically choosing the right PAC unit and the chiller with the free cooling, direct free cooling, indirect free cooling would give you the best in class efficiency, would obviously increase the COP and then obviously decrease the COP number. From an indirect direct free cooling, I kind of shift gears towards the emerging trends in a large hyperscale data center. So let's take an example of a large hyperscale data center. Instead of placing, let us say 30 or 40 TR multiple units and having multiple chillers, multiple indoor units, we also look at the trend of placement of fan wall units. What are fan wall units? These are large customized, I would say, a air handling unit where it is placed directly on the slab. So we eliminate the false floor, completely customized to meet larger capacity and larger airflow CFM. So we eliminate false floor, the cold air is given, and we do a hot-air containment back to the unit. Obviously, these units would be connected to the chiller, can be single or can be multiple chiller, dual coil, maybe chiller A operates, and then when the chiller A is shut down, chiller B comes into picture. So as I said, these are the fan wall units. What is the major advantage we see most of the time in a data center is that we have a false floor. With this methodology, we could actually eliminate the entire false floor setup. As I talk, you can see what goes into the false floor setup. Again, it depends upon the application demands and requirement, but as a case study, if there is an option, we could completely eliminate and place the units directly on the slab, thereby saving your operational and your, more importantly, the capital cost. So with this is one of the emerging technology what we find in the data center. So as a conclusion, we spoke on what goes into the ISHRAE norms, what is the methodology, what is the solution, and the free cooling. As a conclusion summary, I would like to quote unquote, the free cooling close control unit COP shall go above 3.5, which brings down the overall PUV to 1.2 or below, which is an excellent mark for any DC space. And with the driving force of energy efficiency, sustainability, free cool would be the right solution to implement at any data center, to go green in a data center, as well to get the savings during the operational period. So choose the right cooling modes with the free cooling close control unit. To kind of pull back that same PUV number, indirect or direct free cooling, the PUV numbers would go down, as I said, 1.08, again depending upon the type of unit. As I said, the global average is 1.59 done by uptime. Choose any cooling unit, direct, indirect, the PUV numbers would definitely drop. I would like to thank everyone.